Okay, thank you very much. Hi everyone, my name is Szilcz, and I'm a postdoctoral researcher at the Karolinska Institute, and I'm also founder of a consultancy company called VT Science, where we specialize in R-Shiny application development for health economics and real-world evidence. And today I'm here to present about extRpolateS, which is an R-Shiny based interactive platform for time to event data modeling specifically for health technology assessment. So in today's presentation, I'm going to introduce you the platform extRpolateS, and then give you also a short background about the extrapolation itself, and then show you how our tool enhances the effectiveness, or like the shortens the timelines for this analysis, and also then lastly go into the discussion section. So let's start with the extRpolateS. So this is an HTA survival analysis platform specifically built for extrapolation, time to event data extrapolation for health technology assessment. And this is a platform for both novice and advanced users, and also we used to make this standardized but still allows enough flexibility for different types of extrapolations that you might need in different countries. And the idea, it actually came from that we use this as an internal tool because we did lots of Kaplan-Meier digitizations and extrapolations for health economic modeling. And then we thought that if we like to use this tool and if it effectivizes our workflow, then probably others will be also interested in it. So what we did is that we started making it as a cloud-based R-Shiny web application where we also focus on security, such as using auto identification and Amazon S3 data storage and Microsoft Azure deployment. So you can see a small QR code on the top right hand side. So you can scan that and join the waitlist, and you will get an email when we launch the product, hopefully very soon. And this will be also visible in all slides, so you don't need to hurry. So let's look at the background about extrapolations. So what we know that clinical trials have limited follow-up time, and because they are designed for regulatory approval, and this means like 24, maybe 60 months in pivotal trials. But for HTA, we need long-term survival difference calculations, and what we can do for this is extrapolation. And this is a graph how it usually looks like, that you have the Kaplan-Meier curve and extrapolate different survival functions on it. And usually we use like a lifetime horizon, especially if in oncology. The current way of working with this is that we either have individual patient level data, or that we have reconstructed IPDs, individual patient level data from Kaplan-Meier plots. So let's look at first how we do it, or what we have, or like the workflow where we have the individual patient level data available. And first, we need to do the analysis in R, and there are several packages available. For example, this AG package, which is great. But the problem is that this needs specialized programming knowledge and quite time consuming. When IPD is not available, it's even more cumbersome because you need to do the same stuff as mentioned before, but you also need to do reconstructing the IPD from the published Kaplan-Meier curve. And how you usually do it is that you take the published Kaplan-Meier figure, you upload it to a digitization software, for example, a Webplot digitizer, and then you scan the curve, and then you fill in the Excel document with the time and proportion, so the survival probability, and that you see on the left-hand side, and then you also fill in the number at risk and time at risk from the for another Excel document, and then you and then you load this into your R software and then run the script for reconstructing individual patient level data. So you need like two softwares basically, and you need to know how to use R as well. What we did is that we streamlined this whole process of not needing to use Webplot Digitizer or coding itself, but you can go through this whole extrapolation process for health economic modeling just by point and click interface. And what we found is that it greatly accelerates timelines, so it's extremely quick to do this, produces HTA-ready modeling outputs, and also enables self-sufficiency. So, for example, for local affiliates with few manpower, they can easily use this themselves and avoid delays. We also made that this serves as a data repository, so you can actually save the data in this application and use that in modeling. So, for example, this is especially useful when you have several data cuts of the same trial and you're doing like early modeling and health economic modeling. So you can actually save several data cuts and then compare later on. But let's look at now an actual demo of the application, because I think that makes more sense than presenting with slides. So this is how the application looks like, the first screen after you logged in. And then you can select to get started with the application. Then you can choose between uploading your data to reconstruct individual patient level data or go for modeling if you have already uploaded data. But let's look at the previous option of uploading data. And here you can choose between 3 different options, such as uploading the Kaplan-Meier plot itself, uploading the digitized Kaplan-Meier data, or uploading empirical data. Let's look at how it looks like when we upload Kaplan-Meier plot itself. And this is just basically using the same upload functionality where you browse the data, browse your files. Then when you have the uploaded Kaplan-Meier figure, you can zoom in or out depending on how like the file size and the file resolution. And after we zoomed in, we just need to follow the instructions that are presented on the top. It says that we need to click on the x-axis and the initial time point and the maximum x-axis value. So we just follow that. And then when we are done, we will show this on the left-hand side that we need to confirm the scaling of the x and y axis. After we confirm the scaling, then we can start digitizing the curve within the R-Shiny application. So this whole process is quite similar as what you would do in a Webplot Digitizer, but everything now is in the same application as well. So this is how it looks like when you have all the points digitized, and then you just need to confirm the data extractions. And then also enter the time points from the Kaplan-Meier plot and also the number at risk from the Kaplan-Meier plot. So you see these numbers correspond to the numbers that we have here. We also see the digitized survival probability and also the time at risk of each points that we clicked. And then when we are done with this, we can actually reconstruct individual patient level data with just one click, which then will be transported down here in this application. So this is where we were, and now we transport it down to the reconstructed IPD. We also see the survival table and also the reconstructed individual patient level data, which we can both download. What's a really cool thing is that how people usually do this is just like visual assessment. Does this Kaplan-Meier curve look like the one that I have digitized here? What we did is actually a function to overlay the curve on the actual Kaplan-Meier figure that we have, so we see how the digitization actually succeeded. So this is the same figure that you have uploaded here. Then you can decide whether you want to save this data to your database or proceed or just reset the tab and start again. if you decide to save this to your database, then you will be shown this characterized your data upload. And this is basically just for standardizing the way how you save data, so it's really easy to find it. So you can upload the same study, different drugs, different indication for the drugs, different treatment lines, database logs for the type of data that you upload for the data, and also different time values that this data is in. Then, if you don't decide not to upload, then you can just proceed without saving. When you click that, then you will be transported to the modeling tab, where you have 8 different modeling options. This is like the Kaplan-Meier, the proportional hazards, and this also makes sense when you actually load in 2 data, like 2 curves in the application. So you can actually look at proportional hazards as well. We have also independent extrapolations, and also splines, dependent splines, cure models, and also like a curve comparison tab, which is a special tab, and I will come back to this later. So let's look at, for example, now the independent tab, and here we have survival plots, hazard plots, or cumulative hazard plots, a goodness of fit table where you can see the lowest AIC and BIC and log likelihood highlighted in green, and also a plot where you can add different extrapolations on top of each other, and also a table showing the restricted mean and also the landmark table of the plots that you have added here. So let's look at, for example, how you change different distributions, which is really easy, just point and click to change the distributions. And then also you can overlay multiple curves on top of each other in the graph in the bottom. For example, now we have added exponential distribution gamma and generalized gamma. And then you can also calculate average the survival estimates with using different weighting methods, AIC, BIC weights, outcomes window, or equal weights as well. You can also look at different splines if you would need more flexible modeling options. And we have like 9 options included, which are the spinal hazards, odds, and probability linked survivors with 1 to 3 knots. You can export all of these results to Excel and export the figures as well, and also the parameters if you want to just plug it into a health economic model. And the same information is presented in this tab, the goodness of fit table, and also the independent, like multiple independent spline plots where you can just stack extrapolations on top of each other. So all the curves are, or the tabs are built into this same fashion, the dependent splines and cure models, but I'm not going to go through them because everything is built quite similarly as I showed you for the independent splines, except that they are specific to the given analysis. But we have this special tab called curve comparison, which lets you plot any curves on top of each other, which means that if you go to this tab and then select the data that you have saved into this application, so you can just click on this data selection, then you will see a pop-up and see the data uploaded into this application. And now we see that we have just uploaded 20 data in this application, and just selecting it, you need to click the actual data that you want to add. And then when you click that, then you see the data, how we characterized it, that this is the study, the drug, the indication, treatment lines, database log, and type of data, and so on. And then we also can add 2 or several different data, so from the same study or from different study, or and so on. Then when we are done, we can click this button called Analyze Selected Data. which will take you to the again like a next selection point where you can decide which of these two that you have previously selected want to analyze. And this makes sense when you want to do the same analysis for these two different drugs. For example, we select the drug A, and on the left side we select the type of analysis that we wanna plot. In this, we have the independent analysis selected, not a piecewise model using general extrapolations, and then you decide which of the distributions that you want to add on this. And using the Add to Plot button will add the plot to the right-hand side. So if I skip a few steps, this is how it looks if I added the Kaplan-Meier plot and also fitted the variable distribution on this example drug A. If you go back here, you can just quickly select the drug B and then also add the same analysis that you have seen for drug A. And then you can also, if you scroll down, you can also add curves based on hazard assumptions, or you can add like this option that we call the apply hazard assumption. This is really specific to actually Swedish HTA, where you can use the comparators hazards during modeling. And then you can also look at the summary table below of the different extrapolations, where you can look at the area under the curve, and also the confidence intervals and medians, and also the specific time horizons that you have chosen here. And you can also change the time horizon to whatever you would like. So let's now go back to the actual presentation and show you the upcoming features that we also would like to extend this application with. So what we are thinking of, or we started implementing, is actually a template-driven partition survival model in this. So making it even more streamlined, that you just you digitize your curve, extrapolate it, and take those curves directly input it into your template partition survival model. You have your costs and qualities there, and then just run the analysis, which will be extremely useful for early modeling. We also would like to include probabilistic survival curves in the application to make it even more flexible with modeling options. And then we plan to deploy it as a software as a service application, or using an enterprise deployment option if companies aren't allowed to upload their data to other services. But if people are using Webplot Digitizer to upload Kaplan-Meier curves, then this is essentially the same. And we are very happy to take any suggestions of what you would like to see as features, and what you think would add benefit to your workflow. So yes, thank you very much for your attention. I'm happy to take any questions or suggestions.
Okay, thanks very much, Mate. I thought that was a really accessible presentation. I wanted to ask you, do you teach in your current role?
Yeah, I take some teachings, but not.
No, I just thought the presentation style was very accessible, and I just kind of thought, oh, this would be exactly the sort of thing we want in a lot of postgraduate education. So I thought that was wonderful. I thought it was just my first reaction. I wouldn't particularly do this type of work in my own work, but it's a very, very clean browser on our interface. And I know this doesn't happen by accident. That takes a lot of work to get something to look so clean. And it's a really comprehensive tool. It's getting great reaction in the comments. You should definitely take a look here. So I mean, some people are asking, is this going to be made open source? A question that I have, are you planning an accompanying paper that demonstrates this tool? Because obviously you've got a commercial market that you're looking for, but also there's a sort of an academic audience as well. So do you have an accompanying publication that you're planning at all?
Yeah, so what we are planning is that for making it probably freely accessible for universities, taking that cost on the companies, because it still costs to deploy this on Azure and use the Amazon S3 data storage and authentication services and everything. So that has a cost as well. But for companies, we plan to use it as a software as a service application. So basically, charge a monthly or yearly fee, which will be much lower than how much time and money you can save with effectivizing your workflow with this application.
Okay, I think I get the impression that there's probably going to be quite good commercial interest in it, given the responses in the comments. So Dawn asks a comment about being simultaneously able to export all the plots and the tables, in the right order that you would need for an HTA submission. I presume she's thinking from the NICE requirements in here, but she's saying this looks like it's going to be very useful for exporting all of the results. Dawn, I don't know if you want to come along and add some of the nuance to your question there, or
happy to do that. So obviously I can see that you had export functionality for each of your plots and your tables individually. But when you're coming to do real survival analysis for a HTA, you probably want to do A, a lot of curves at once, and B, you want all of the results to come out at once in the template where you can write around them, essentially. So I can see at the moment there's quite a lot of manual copy pasting possibly, and that's error prone. So is that something you could look at for a future iteration?
Yeah, thank you very much. That's a great comment, and that's certainly that we should implement, just like a generate report functionalities where you can just click in what you would like to export. And also I was thinking of making it like LLM enhanced, where you can also get some explanation for your results.
Yeah, exactly.
So that making it everything much more streamlined and even less work. But that's that definitely I'm gonna write that up and make sure that you can generate reports.
Thanks, Matti. And also there's a question from Yang. Does this tool support accelerated failure time models?
I will need to. Yes, it will support. Yes.
Okay. And I was just going to ask you just some notes that I'm making as I was going through the presentation. Have you submitted an abstract to ISPOR? Because I was thinking that's probably one of the ideal audiences for this work, given the kind of the commercial interest that there might be.
Yes, exactly. So I haven't sent it yet. The deadline is I think 26 or 27, so I still have time. But I will send in a ISPOR accept about this. Yes.
Okay, good luck, and I hope the reviewers see the value in this. I think this would be useful. I just want to ask you a practical question. Just a lot of these tools, they're very appealing, but when when you rely on uploading a plot, sometimes you're uploading a grainy plot and so on. Do you run into any practical issues when you've tested this in terms of real world papers, stuff that you've come up with?
I mean, not more than with other softwares. So this, I mean, the general recommendation is to have a plot that you can see and digitize. But since the digitization portion is not automatic per se, that you actually as a user need to click and point at the curve, so it all depends on you being able to see the curve. Yeah.
Okay, super. Okay, and then I was also going to ask, maybe just because a lot of people who are coming from not necessarily the application position, but some people interested in terms of building web apps and building things. I wanted to ask, what were the issues that you encountered from building such a nice tool? I mean, I imagine the development time was massive for this, but was there any particular bump in the road that was particularly difficult?
Yeah, I mean, making it as a SaaS application where you can actually sign up and handle different users, that was challenging, but with a combination of Auth0, we managed, and also Amazon S3 storage, we made it possible. But that was maybe the most challenging part. And also, I mean, this is a huge code as well. I said, the code base is huge, so we had to modularize everything and then make sure everything is well organized and well kept, and the code is efficiently running, because if we're not going to run it on the shiny apps.io server, but we're going to run it on our own server, on with Docker containers, then it's really important that it's running efficiently.
Okay, there's quite a lot of skill, I think, needed to understand all of those things for the appropriate implementation. So Zach has come in with a question towards the end, and he's asking, when you export, do you export all the app settings when you export a figure? So I think this is, because there's a lot of things that you need to click as options. Are they all recorded whenever you go to an export output? Is there a say like a text file that goes with everything that's being selected?
Yeah, so how it is currently, that when you export something, then you see the uploaded data's name and how you characterized it, so you can identify what's being exported, and also the model that you have when that you extrapolate it. So if it's exponential variable or any spine models, then you see all those options. But definitely, as also Don talked about, having a generate report functionality that will include all the options and settings that.
Okay, super. I think that answers Zach's question very well. Okay, super, Matthew. Thanks very much for that presentation. That was lovely and clear. Thanks very much there.
Yeah, thank you very much for